So here we were discussing about the behavior of gases. Uh, so in that what we discussed is about the matter. Matter is nothing but anything which has a mass and occupy the space is called as a matter. And matter can be classified in mainly two ways. One is called as based on the state, and second is called as a composition. And based on the state, we are going, okay, matter can be classified into solids, liquids, and gases. And based on the composition, pure and mixtures, right? And next we discussed about the properties and the force of attraction. The four types of force of attraction, these all we discussed. And measurable properties of gases: volume, pressure, temperature, and number of moles. So these are the important thing. And okay, gas laws. Let's come to the Boyle's law. So what is Boyle's law? Boyle's law states that at a constant temperature, means when the temperature is maintained constant, the volume of a given mass of a gas is inversely proportional to its pressure. Means what? Volume and pressure are inversely proportional to each other. The meaning is that if the pressure increases, volume decreases. If the pressure decreases, volume increases. So both are inversely proportional to each other. Mathematically, it can be written as V is proportional to 1 by P. Like this we can write, okay? V is proportional to 1 by P. Okay, where V is the volume, this V is the volume, okay, and P is the pressure. Okay, and when you remove this sign, okay, so I think you know this one already in the mathematics, already we studied so many times. So when it is 1 by P, when you remove this sign, then we get one constant. Do you know that? So what we'll write now? V is equal to, instead of this sign, we get one constant. So we write a K. And here what is there? Into 1 by P. So now this becomes V is equal to K into 1K by P. So we can write like this also. So V is equal to K by P, where K is called a constant. Okay. Now, if V is equal to K by P, here P is the denominator, so we are bringing this side. So on bringing this side, it becomes what? P into V. So PV is equal to constant. PV is equal to constant. So you have to remember this one. If PV is equal to constant, we can write like this also. Like P1 V1 is equal to P2 V2. Okay, is equal to P3 V3. Okay, like this we can write up to Pn Vn. Is this clear? How can we write like this? So for example, you see, for example, let's imagine we have some number like 40. Okay, so this 40 is constant. Okay, so here what I am doing, here I will take, for example, I am telling you take this is V, this is P. Okay, now this is what we have, PV is equal to K. Okay, means what? P into V is equal to K. If so, into is equal to K. K means what? Constant, that is 40. If I write 1 here, so what I should write here? 40. If I increase this one, 1 to 2 I will increase. Then here what can I write here? This is remains constant, this same constant. Okay. So now what can I write here? 20. If I write here 4 here, what can I write here? 10. If I write 5 here, what can I write here? 8. If I write here, okay, so 8, so I can write 5 like this. So here if you see, here one quantity is increasing as we come top to bottom. 1, 2, 4, 5, 8, it is increasing. Yes or no? And here what's happening? 40, 20, 10, 8, 5. Means what? Here it is what's happening? Here it is decreasing. Is this clear to you? So this is increasing and this is decreasing. Yes or no? So this is called the inversely proportional. So one quantity increases, other quantity decreases. But the product always remains the same. But the product is always remains the same. So if you take this value is V1, then this value becomes P1. If this value V2, this becomes P2. If this value is V3, this becomes P3. This value is V4, this becomes P4. This value is P5, this value is P5, but always this remains same. Okay, so this is constant K. The meaning is what? P1 V1 is equal to K, P2 V2 is equal to K, P3 V3 is equal to 3. Okay, like this. Is this clear to you? So like this, so we can write volume of a given mass of a gas is inversely proportional to pressure. So when you remove this sign, we get one constant. So we can write V is equal to K by P, where K is called a proportionality constant. Here in the P is in the denominator, so we bring this side, it becomes P into V. PV is equal to constant. If PV is equal to constant, then we can write P1 V1 is equal to constant, P2 V2 is equal to constant, P3 V3 is equal to constant. Like this, we can write any number of this one. Is this clear to you? This is called the Boyle's law. Any doubt in the Boyle's law? So very simple. If the pressure increases, volume decreases. If pressure decreases, volume increases. That's all. Okay. Now we have to remember this is most important thing, that V is inversely proportional to P. Remember this one, this because we are going to use this formula in deriving the ideal gas equation. Okay. Chalo. If you want to take a screenshot, you can take a screenshot for this one. Right. Now go to the Charles law. So here we have taken total 4 things. You remember that? Okay. So 4 things you have taken. What? One is volume, one is pressure, one is temperature, one is number of moles. These 4 things only we have taken. Okay. So even in the last slide also, V and P, where temperature is kept constant. So here what we do in the last, means in the Boyle's law, we kept a T constant. Of course, N is also constant. Okay. But here what we are doing is, we take the P constant now. What will you take the constant here? P constant. In the last slide, the Boyle's law, we kept the temperature and N we kept the constant. But here we keep the P and N keep constant. Okay. So now in this Charles law, what we are going to do is, we are going to take the relation between V and T. Okay, V and T. So V and T, and we are here keeping the constant P and N. We are keeping the constant P and N. Is this clear to you? Now what happens when the pressure is maintained constant? The volume of a given mass of a gas is directly proportional to absolute temperature. The volume is directly proportional to absolute temperature. Means as the temperature increases, volume also increases. Okay. So this already I think you might have learnt in the lower classes. Yesterday also I think I might have told. Okay, this is empty bottle, and to this empty bottle you take one balloon. Okay, so take one balloon, and this balloon, okay, you keep like this balloon. This is balloon, no air. Okay, now what you do? Now heat the empty bottle. Okay, now heat the empty bottle. You heat it here. From here, you heat it. On heating, what happens here? Whatever the gas is present inside, this gas get expands on heating. What happens? It get expands. Okay, expands on heating. So that expanded gas enter into this balloon. Now after some time, if you see, the balloon becomes like this big. It becomes. Okay, so from where this air is come? This air is come from this only, or whatever the inside bottle is, that much air only. But on heating, what happens? It got expanded. It got expanded. That expanded means what? Its volume is increasing. Is this clear to you? So the meaning is what? Volume is directly proportional to temperature when you keep the pressure and the mole, okay, kept constant. So see, a Charles law states that the volume of a gas means V, okay, is directly proportional to the absolute temperature. Directly proportional to means what? This sign, absolute temperature. So absolute temperature, okay, where the pressure is kept constant. Okay, so the meaning is what? V is directly proportional to T. So V is directly proportional. V is directly proportional to T. Okay, so what we can write here? V is directly proportional to T like this. Now, just now I told you that when you remove this proportionality sign, we get one constant. So remove is equal to one constant we get, so K into T. Okay. Now here K into T. So this T you bring this side. So on bringing this side, what happens? This into. So when you bring this becomes what term? V by T is equal to constant. Yes or no? V by T is equal to constant. Now what we do? V by T is equal to constant. So this we can write V1 by T1 is equal to V2 by T2 is equal to V3 by T3. Like this we can write any number Vn by Tn is equal to constant. So this is called Charles' law. Is this clear to you? So this is ratio of V by T. Ratio means what? A division. V by T is a constant when the pressure is kept a constant. That's all. So this is known as the Charles' law. So Charles' law, what it states is, at the constant pressure, the volume of given mass of a gas is directly proportional to temperature. Means as the temperature increases, volume also increases. So V is directly proportional to T, or V is equal to, when you remove the proportionality sign, we get V is equal to KT, where K is called proportionality constant. If you bring T this side, then we can get V by T is equal to constant. This we can write V1 by T1 is equal to V2 by T2 and so on. So this is known as the Charles' law. Is this clear to you? Take the screenshot, and now you have to remember this one. This is in the last slide what we have seen, V is inversely proportional to P. This I said you to remember. Now in the next slide what I have seen, V is directly proportional to T. So here also V is there and here also V is there. Remember that. Okay. Is this clear? Take the screenshot of this one. Right. Now come to the third one. Third one is Avogadro's law. Avogadro's law, it is very simple. Now see, in the last slide I said that what we are using. So here, in the last slide here, we are taking first slider, in the first slide, Boyle's law, what we have done, V, P, T, N, these two kept constant. In the second one, what we did, V, T, we have taken, P and N kept constant. Now we are taking V and P, so what we should take constant now? Here V and now left what? N. Now what should be kept constant here? Pressure and temperature. Very good. Now these both we kept constant. Now we find the relation between these two. Okay. So that is the third law. So third law is what? Avogadro's law. Avogadro's law states that under similar conditions of temperature and pressure, means what? Pressure and temperature should be constant. Okay. Under similar conditions of temperature and pressure, equal volume of all gases contains equal number of molecules. Equal volume of all gases contains equal number of molecules. Very simple. Okay. So Avogadro says equal volumes of all gases at the same temperature and pressure have the same number of molecules. Here, equal volume of gases contains same number of molecules, equal number of molecules. When the temperature and pressure kept constant. Is this clear to you? Okay. The meaning is what? We can write like this now. So we can write V is directly proportional to N. What we can write here? V is directly proportional to N. So this way what we can write, V is equal to, when you remove proportional sign we get one constant. So we write K into N. Okay. Now N bring this side. So this becomes what? V by N is equal to constant. If V by N is equal to constant, what can I say? What I said to write? We can write V1 by N1 is equal to V2 by N2 and so on. So that is called Avogadro's law. Is this clear to you, Avogadro's law? Under similar conditions of temperature and pressure, means what? Temperature and pressure should be kept constant. Temperature and pressure should be kept constant. Then V is directly proportional to N. When the pressure and N are kept constant, then V is directly proportional to temperature. When T and N is kept constant, then V is inversely proportional to, that is Boyle's law. So this is Boyle's law, this is Charles' law, this is Avogadro's law. Clear these three laws? So take the screenshot of this one, third law. Now by using these three laws, we are going to derive the ideal gas equation. Which equation we are going to derive? Ideal gas equation. So, ideal gas equation, how can we derive the ideal gas equation? So, here you see now. Okay, ideal gas equation. Ideal gas equation can be derived. Okay, so see here, ideal gas equation can be derived from the three laws. Which three laws? Very good. So now see here, from Boyle's law. From Boyle's law, what we have? V is inversely proportional to P. Yes or no? This is the first one. Now second one. Second one, which one? From Charles law. From Charles law. What we have the Charles law? V is directly proportional to T. Yes or no? This is the second law. Next, third one. Third one is what? Avogadro's law. Now, what is Avogadro's law? Third one, from Avogadro's law. Okay, what we have? V is directly proportional to N. Okay, this is the third equation. Now see, V, proportional, proportional, proportional. So all are same. Yes or no? So now we combine all the three. We combine all the three. Okay. So from equations 1, 2 and 3. See, in all V is common. So we are writing V. And then all proportionality sign is common. Proportionality sign. Now we write one by one. So first equation what we have? 1 by P. Second equation what we have? T. Third equation what we have? N. Is this clear to you? Now what we do? V is proportional to 1 into T into N, N. So it becomes Tn by P. Clear? Now what we do here? V is equal to, I said that when you remove this sign we get one constant. That constant here we take, okay, R we take. What we take here? R. And this side what is there? Tn. So write it Tn by P. Okay. Now this P bring this side. So in the denominator it comes here numerator. So PV is equal to nRT. We are rewriting this one. So we got this one. This equation is called ideal gas equation. Very, very important one. Okay. This is called PV is equal to nRT. What is the equation? PV is equal to nRT. Okay. So here this is a PV is equal to nRT here. According to Boyle's law, we have that V is inversely proportional to P. According to Charles' law, we have that V is directly proportional to T. According to Avogadro's law, we have proportional to N. Joining all the above equation, then V is proportional to N into T by P. Or a V is equal to constant, that constant we are taking as R. So final equation what we get? P if we are bringing here, PV is equal to nRT. So this PV, okay. So this PV, okay, this PV is equal to nRT. This is called ideal gas equation. Is this clear to you? Chalo, take the screenshot of this one. So with this ideal gas equation, this is a very, very, very important basic law in the okay, in the states of matter or behavior of gases. Okay, and this is a very, very important topic in the 11th class. In the 11th class, this chapter is very important because of based on this, we have so many chapters are there where we can use this ideal gas equation. This ideal gas equation can be used in the physics also. We can also use it in the chemistry also. Is this clear to you? And based on the ideal gas equation, means based on this equation, in the main IIT mains, at least you will get 3 to 4 questions. okay, in the chemistry, and 2 to 3 questions from the physics also. So that's what it's a very, very important law. Is this clear to you? Chalo. Now after this, I think slides are done. Okay, but now we have, okay, 2 more laws are there. That 2 more laws also we discuss. Okay, 2 more laws also there. Then we discuss 2 more laws. So this ideal gas equation is done. Now next, what is there next? What's the next topic in your textbook? I think Graham's law of diffusion. Next topic is Graham's law of diffusion. Am I correct? Graham's law of diffusion. So here diffusion means what? Mixing. What is the meaning of diffusion? Mixing. Okay. So for example, you see here this is a room, right? In this room I am at one corner. For example, you think I am at one corner. At other corner, so this room is very big room. So in this other corner, for example, you are taking, or someone is okay, spraying the perfume to his body. Okay, there at some corner. Now within seconds, I can smell that perfume. Yes or no? So this property is due to diffusion. This property is due to diffusion. And the diffusion is there, effusion is also there. Effusion means what? Releasing from through the small hole. Okay, releasing through the small hole. Even for example, perfume bottle is there. You need not to press, just to open the, okay, this one. So you can wait for some time. Within some time you can observe that the smell will be spread throughout the room. Okay. So here even it's a small hole is there. So that comes from that high pressure to low pressure area. So this phenomena is called effusion. What it is called? Effusion. Diffusion and effusion. Is this clear to you? Right. So here Graham's law of diffusion, very simple law. This also, this is okay. This law what it states is the rate of diffusion. Here not directly diffusion. You have to say that the rate of diffusion. The rate of diffusion of any gas is inversely proportional to its density. What is given here? Inversely proportional to. So rate of diffusion is denoted by R. Denoted, okay, and rate means what? Actually within a particular amount of time. Okay, rate means what? Particular amount of time. Okay, rate means what? Within particular amount of time, how much gas it is releasing, coming out. That is called in a particular amount of time, how much gas is mixing, how much gas is coming out. That is called as a diffusion, rate of diffusion. So rate of diffusion is inversely proportional to square root of its density. This is the formula, and if you want to write the definition, so definition how can you write is okay, you write the same thing. Okay, the rate of diffusion, okay, is inversely proportional to, okay, inversely proportional to the square root of its density. Okay, so this is the rate of diffusion of any gas you take here, of any gas. Okay, the rate of diffusion of any gas is inversely proportional to square root of its density. Here R means rate of diffusion. Here inversely means what? 1 by, okay, in the denominator we write, okay, reciprocal also we can say. So inversely proportional to square root of its density. This is a square root symbol. Here D stands for density. So this is called Graham's law of diffusion. Clear to you? Note down this one or take a screenshot of this one also. Right. So Graham's law of diffusion is one of the important basics law. Actually, it can be written in different forms also, because density is density formula, you know, density is equal to mass by volume. Density is what? Mass by volume. So you can substitute in the place of D, mass by volume also you can substitute, molecular mass also you can substitute, so many things you can substitute, so that this can be written as in different ways. Okay, clear to you? Right. Now then come to the Dalton's law of partial pressure. What is the next one? Dalton's law of partial pressure, this is very simple, I think you know. Okay, it's very easy. So Dalton's law of partial pressure, what it states is, here for example we have the two gases, you think. Okay, for example we have the two gases. Let's imagine that we have two gases are there. Okay, here you see now, I'll go to the next slide. Here I have one box. Okay, this is one box. Alright, now here I have one more box. Okay, like this. In this, okay, some certain amount of gas is there. For example, I am taking oxygen. Okay, here I am taking oxygen gas. Here I am taking, for example, nitrogen gas. What I am taking? Nitrogen gas. And the condition remains same. Okay, means what? The temperature and pressure kept constant. Okay, so here, for example, under some similar conditions, now you know that gases exerts the pressure. Okay, you know about the atmospheric pressure. Atmospheric pressure means what? The pressure exerted by the atmosphere. Atmosphere is nothing but a mixture of gases. The pressure exerted by the gases, okay, is called atmospheric pressure. The meaning is what? Gases exert the pressure. Is this clear to you? So now let imagine that. Okay, so here the pressure exerted by this oxygen gas is P1. What is the pressure exerted by the oxygen gas? P1. Now let's take the pressure exerted by the nitrogen gas is P2. Okay. Now what I am doing? I am taking the similar box, same size box I am taking. Now this both the gases I am transferring into this one. Okay. This both the gases I am transferring into, okay, the third box. So in the third box I am mixing both the gases. Okay. Now if I check, okay, this pressure, what I will observe, the total pressure exerted by the oxygen nitrogen equal to, very good, that's all. That is the Dalton's law of partial pressure. So P1 plus P2. So this is called the Dalton's law of partial pressure. So how can you see here? Partial pressure means what? Partial pressure means what? The pressure exerted by the individual gas. Individual means what? Single gas. The pressure exerted by the individual gas, single gas, is called partial pressure. Okay. So now how can we define the Dalton's law? So here, how can we define the Dalton's law? Very important law. So Dalton's law of partial pressure. Okay. So what it says is the total pressure exerted by the mixture of non-combining gases or non-reacting gases, anything you can say, non-combining gases is equal to sum of the partial pressures of individual gases. That's all. So here the total pressure, okay. So the total pressure, let you think this as a P. The total pressure exerted by the mixture of non-combining gases is equal to sum is what? Addition, okay, of the partial pressures of individual gases. If you are mixing two gases, then we can write P1 plus P2. If you are mixing three gases, we can write P1 plus P2 plus P3. If you are mixing n number of gases like this. So this is known as the Dalton's law of partial pressure. Is this clear to you? Right. So take the screenshot of this one. So with this, the topics of chemistry is done. So this is the last and final law, Dalton's law of partial pressure. Okay. So here with this we complete the chemistry. We conclude the chemistry. And tomorrow, do you have a class? Thursday, I think you don't have a class, no? Friday you have a class. Otherwise, you do one thing. Yeah, Visha. So Friday's class tomorrow, if we postpone, so Friday you'll tomorrow Thursday no. So Friday's class if you prepone to tomorrow, then Friday you'll have a 1 day time. You take that time for the as a preparatory holiday, and Saturday you write the test. What do you say? That you think with your next who will be coming next, sir, physics item. So when the sir will come, you think and you decide. Then you inform to sir. So accordingly, we can make it. Okay. Okay, then bye. You can take a break for 5 minutes. After that, we'll have. Okay. Right.